Good morning, everyone. Today we are going to jump into the dummy and see what we can find as far as functions. And maybe write down some useful stuff. So, just got home from a 14-hour shift at work. A little tired, so we'll see how this goes. So, let's open this sucker up in Ollie. And it breaks here. And since we know that this was compiled in dev C++, we can just, and that it's not packed. One way you can find this out is if you right click it and open with PEID, it will tell us a lot of the times whether it is packed or not, and sometimes even the compiler that was used to compile it. I thought it usually recognized Borland or C++ or dev C++, but guess not. Anyways, so back into it here. With knowing that though, you can scroll up and eventually you'll see something that looks like this. A bunch of junk. You see a C exit call, and above it you'll see a call to a address, and that address every time is the beginning of the user written code. And if we just start looking at it, if we just disregard this chunk here, which is just setting up the scope for this chunk of code, we'll first see a call to set console title A with one argument, and it's a string that says dummy. Excuse me. Still a little under the weather. And then if we look down, we see this junk, which looks a lot like something we've seen before. Oh, wait, yeah, look at that. A call to register class. So this is setting up a window class. Okay, cool. And then it says, well, if the registering of the class didn't work, then go ahead and run this and return. Actually, what this reads is, if it works, jump over and continue. Yeah, I had to pause the video and I just started again. I don't really know what I was saying, but I know where we're at. And I think I was saying what this actually says is so it's testing AX, and if it's 0, then to continue. Otherwise, well, okay, it doesn't really say that. I don't like it when compilers do this, because what it's actually saying is if it's not 0, so if it's not, then continue. If it is 0, then return and just quit. So if it's not 0, so if it is 1, or if it is good, go ahead and come down to, hey, this looks familiar too. Oh, look, create window. Look at that. Hey, we've been here before. If we look at the code, here's our register window class. Here's create window. Okay, hey, look at that. Things match right up. It's really not that hard, people. Anyways, so then we're going to come down to seeing that little sleep loop that says, hey, I'm waiting. But it does that within, oh no, this isn't that sleep loop. This is the hiding of the window. So this is sleeping until it finds the window. And then we're going to see hide the window that it just created. And then it's going to say, I'm some program. And then it's looking at the messages, translating, dispatching messages, sleeping, and saying I'm waiting. So it's kind of hybrid of a message loop with a I'm waiting string output in it. So where's the switch for this message loop? If we remember from register class, the third argument is the callback procedure. So if we go 1, 0, 2, the name of the class, 3, hey look, the address to the callback procedure. Alright, let's go to expression 40138C. Well, yours is not going to look like this, but if I analyze, it'll look like this. Ollie likes to try to make things look as neat as possible, but sometimes it does this sort of thing where you want to actually highlight it all and go to analysis and remove the analysis, because now it's actually useful information. And we'll see here's the top of it. No, that's not the top of it. The top of it was actually right here. And it loads into ESI the address that's at ESI. Okay, cool. Does some storing of the registers so that we can return them back to what they were originally. Sets up some space on the stack. And then it proceeds to move in some variables into these registers. And then it gets a little weird. Compare what's in EBX to 1122. If it's equal, jump down to here. Call this move EAX, what's in EAX to the top of the stack, which this is equivalent to saying push EAX. And this is something that dev C++ does. It's a type of calling. I'm so tired. There's a word for it. Style. It's a calling style. So this is the same as saying push EAX. But instead of actually adding it to the stack, it's modifying what's already at the stack, or on the stack. And it does that because we made room on the stack for our stuff already. So we actually want to undo that because we are going to also clean up the stack. Well, it'll also clean up the stack. But it takes up more space to do this way. Convention. That's what I was looking for. Calling convention. Got it. So if we look inside this call, press enter to follow calls, jumps, stuff like that, we see that it's going to set up some room on the stack again. For this function's, I always want to say frame, but I believe the correct term is scope. And then it's going to output, I do something with no arguments and return a string. It's going to output that, and then it's going to obviously put a string in EAX, clean up the stack, and return. Press minus on your numpad to go back. And then it's going to output the return string. So this is actually a function within the message loop that calls a function. All right, cool. Now, I did say that I put in a message loop in the dummy to call the functions that we're looking for so that they would be referenced somewhere. Didn't have to do it this way, but I did. All right, so what if it's not 1122? All right, it says JA short blah, blah, blah. Well, what the hell is JA? Well, Ollie has this awesome thing where you right click, and let me scroll up or down a little bit so we can, and then help on command. It'll say jump if above. Well, that's pretty self-explanatory. And if we look at the example, it'll say jump will be taken if A, treated as unsigned number, is larger than the unsigned B. Okay, so let's look at this. A is what's in EBX and B is 1122. So if it's larger, if A is larger than 1122, then we're going to jump down to here. We're going to compare it with 1133, and if it's equal to 1133, we're going to run this function. And we're going to actually push the offset I output strings and then call a function that, hey, look at that, it outputs strings. And then jump back and clean up the message loop, or the callback procedure for the message loop. All right, so what if it's not? It's not equal. Well, we compare it with 1144, and if it's not equal to that, we clean up the message loop. Well, if it is, obviously, this will fail and not jump and run this chunk of code, which will then jump up and clean up the message loop. This looks an awful lot like a switch statement. Hint, hint. And what it says is move ESI to the second argument slot, move what's at this address to the first argument slot, do a call to this function that says new value. Okay, sub ESP, move EBX argument 1, move EAX argument 2, move to EBX what's at the address, well, move what's in EAX to the address that is held in EBX. Move what's in EAX to the second argument of the stack. Move this offset new value to the first argument of the stack, and then print it. Okay, so that is going to change our first argument. Yes, our first argument that we pass into our second argument. Well, that's easy. Pressing minus again, we get back to here, and then it says I exited the program by modifying an int pointer, and we see that we sent it 40200. If we follow that and dump, we see that it's set to 1, so we can roughly assume that if we set it to 0, it exits the program. So perhaps the program runs in a while loop that says while running equals 1. Okay, that's probably a safe assumption, and then obviously it cleans it back up. So what if it's not greater than 1122? Well, then it compares it with 1111 and jump if not equal to, well, the cleanup. Well, if it is equal, do this code. And it does some math, and then it says we mathed the output. And this is loading addresses into registers, doing some multiplication on them, actually multiplying all three together, moving EDX, this big ass number, moving EAX, the product of our three numbers multiplied together, and then multiplying by EDX. And then it's going to shift the arithmetic right 1F times, which is 31 times. And if this is a compiler optimization, the math in the code most likely was not this. Compilers optimize arithmetic operations such as division in ways that it is done faster on the CPU. So what this is actually doing is multiplying by a large number and then shifting it right, moving the decimal point 31 times. So what this would actually break down to if we just take this number and divide it by 1F. 1, 2, 3, 4, 5, 6, 7, 8 divided by 1F, not 1, 4, 1F equals this ungodly number. But it's not doing a division that way. It's basically saying divide by 10 31 times. So you take 5, 5, 5, 5, 5, 5, 5, 6, divide by 10. Wait, that's wrong. We're in hex. 10 is A. Wait, we weren't in hex. We should have been. 1, 2, 3, 4, 5, 6, 7, 8. Divided by A equals. That's 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh, we ran out of numbers. Okay. Now what? It can get confusing, but once you learn this, you'll recognize this as, hey, it's dividing by 3. All right, I get it. And then it's going to say, hey, we mathed the total outcome of that operation, and loading these variables in with an offset of +2, +4, +7 is saying whatever we pass in our L-param, most likely, or our argument 1, add these numbers to it and then do this math. But it's not really important. We can just call this function right here with an argument and just do the math and get an output. We can see what it does. And then from there, it's going to just go into the cleanup. Okay, so we found some functions. One that starts here, one that starts here, well, not there, here, here, and here. And then we see this one up here that looks an awful lot like that one that we saw up there. So that's another compiler optimization. It inlined this function. So we could just use this one here. All right, so I think that is going to be it for this video. We're pushing about 18 minutes. And we were able to find a function here that when you call it, it does nothing. It outputs a string and it returns this string. So probably not going to be very useful to us in our program that we're going to use. This one just outputs strings. Well, we could just use our own printf, but hey, it would be fun to use theirs. And then this one modifies a value to be equal to what we pass as a second argument. Okay, that could be fun. This one does some stupid math. Basically an average. So it's first argument, second, well, first argument plus 8, first argument plus 4, first argument plus OC. Move EDX 5, 6, move EAX, ECX, multiply by EDX. And it's doing this multiplication here instead of actually loading them. And it's, you know, move ECX this, multiply ECX by that, multiply ECX by that. Do some more multiplication, shift it right, which is a funny way to look at division. But division takes a lot more CPU cycles than multiplication and shifting. The best example I have is dividing by 2 is the same as multiplying by 1/2. Dividing by 4 is the same as multiplying by 1/4. So that's what this is doing. But it's doing it in a large division and then moving the decimal. So yeah, the math that goes behind actually finding that is pretty simple, but it looks a lot more confusing than it is. And I will look up a little bit easier example of that in decimal. I'll come up with one for us. But for now, it's, you think of it as it's multiplying by 0.33 instead of dividing by 3. But since you can't get a perfect divide by 3, you end up with this 0.3 repeating, and it doesn't know whether to round up or not. We didn't tell it to, so it can't. If we did an even number, it would be nice and easy math here. Anyways, yeah, video's 20 minutes now. We've found some functions. We are going to reference those functions. Probably not in the next video. The next video will probably be the same thing, but in IDA. And with that, we can actually do some labeling. And then from there, we will reference those videos, or not videos, those functions in our program and use them to do something. We'll probably modify some variables, probably output some strings, and we'll probably call them all just for shits and giggles. Again, I feel like this video is kind of lacking. I feel like I could have done a little bit better explaining things. But we are going to go over it again with IDA, and we will revisit this a little bit when we're pulling the functions out to put them into our program. So if you feel a little overwhelmed, I'm sorry. I didn't really want to make this video as long as it is already. Yeah, if you guys want, I can break this video down into like maybe 3 videos that's a lot more in depth. It'll be the initialization of the program, and then it'll be, you know, finding the functions where they're referenced, and then it will be, you know, breaking down each function individually, how they work, what exactly they're doing. But we are going to get into that a little bit more when we're deciding which ones we're going to use in our program. So again, we are going to come back and look at this. If you feel like you didn't learn anything, I'm sorry. But once we get through this, we're going to kind of slow down a little bit. Yeah, as always, thanks for watching. Tell your buddies. More importantly, I need to get some sleep whenever I can. Probably not for another couple hours, but housework, junk like that. Yeah, been awake a long time. Anyways, today's a good day. Why? Every day's a good day. Thanks for watching.